Welcome back to Boiler Bytes. Have you ever boiled a pot of water and noticed how the bubbles rise to the surface? Well, in outer space, without Earth's gravity, bubbles behave differently. That's what makes the special method of flow boiling so important to astronauts. In spring of 2016, Purdue students in the School of Aeronautics and Astronautics designed their own flow boiling device. And with the help of NASA, they got to test their experiment aboard a zero-gravity flight called the Comet.
Here on Earth, we use boiling and condensation frequently in refrigeration cycles, such as in your refrigerator, air conditioner, and whatnot. And we use them to move heat from one place to another. And that process in spaceflight is much more difficult because you don't have the buoyancy that pulls a bubble away from the heater surface and lets more liquid get into the hot area.
In zero gravity, bubbles don't necessarily float up because buoyancy does not exist, because gravity does not exist. So that means any sort of system that we have that has some sort of boiling effect, whether it be ovens, whether it be refrigerating cycles, they don't necessarily work in space.
So it's been known for a while that the solution is to do what's called flow boiling, where you pump the liquid past the heater surface.
So we're using an agent called FC72. Its boiling temperature is around 54 degrees Celsius instead of water. We have a pressure chamber anyway that's going to hold the main bulk of all of the liquid that we have. On this side, this big red thing over there, that's our heater that's going to heat up, all the stuff that's in there. It's going to run over 4 different test sections. Those test sections, we're going to be able to see the bubble formation effect anyway. Up here we have all of our electronics that are hooked up, obviously lots of wires. Going to run through this computer where we have a very large LabVIEW program that's going to end up giving us all of the data that we need. And finally up here, the most important part are our HD cameras, very small. Also with the use of capillary motion, we can try to pull those bubbles out and off of those surfaces. And if we do that successfully, then we can be able to have things like refrigerators and ovens and whatnot up maybe on the ISS, maybe on future spacecraft.
We went down in February to Orlando, so that was nice leaving Purdue. Drove down 15 hours.
Yeah, it was definitely a bonding experience, the 16-hour car ride.
When we went to Orlando, we spent every day at the hangar just like checking for leaks, fixing leaks, making sure running, making sure that nothing is gonna go wrong.
I'm definitely more of the programmer in the crew. I actually was in computer engineering before I switched to aerospace. So having to think of a solution very, very quickly. The amount of times we drove to the hardware store and back.
The experiment is bolted down to the plane, so it's experiencing the gravity that the plane is experiencing.
We had to make sure this is gonna work, nothing is gonna start flying around, or we had to think of all kinds of scenarios that could happen.
We're in this big plane, a Boeing 727. It's got 3 engines, and they've taken all the seats out. There's a lot less weight in there. So this aircraft literally is just shooting up like a rocket. You pull about 2 Gs at the bottom. They call it the high G maneuver. So you fly in the sinusoidal pattern. And when you end up reaching the top of the arc, have you ever been on in a car and you go and you feel a hill, and it's one of those hills where you just get this little bump and you feel a little bit of weightlessness there? It's basically that, but for a really long time.
I was just ready to go. I'd been ready to go the whole semester since I'd heard about it, because I was just experiencing zero gravity. It was really cool. I was very excited.
The very first parabola that they have people try to get acclimated, everybody says, boom, they just go and hit the roof of this thing. You're not used to it. You don't realize that a tiny little bit of force is what's really needed to actually maneuver your body around.
You could feel when the zero G really happened, you could just float, kinda. So I was just holding myself in, right next to the experiment. Felt like you were in water, pretty much. But if you do this, you don't move. You just stay there.
It's like you're swimming, but then you go like this and you don't move. You don't push a fluid back. And it was just really odd, just being suspended in nothing for 30 seconds each time. It was great.
The first 5 parabolas I kept getting a little yelled at because I was so short that everyone else could touch the top and the bottom of the plane to control themselves, and I was just floating off. And every time they were feet down, coming out, we were ending the parabola, there'd be someone reaching up and grabbing me and pulling me back down. But after 5, you got used to it.
It's a great form of teaching, flying with your students in weightlessness. The experiment worked great. Everything was in good order. When we set it up to run in an automated state, it ran very well automated. So students have done some really good work getting it ready for flight.
For the most part, I think we were pretty pleased with it. We got excellent data, I think. It's going to take us several months to actually process all of this data and get it all ready for NASA.
We're looking at the videos from the bubbles. It's also a very tedious work.
Well, the biggest thing we're doing is by looking at the bubble detachment and like the length that they connect to the surface, you want to increase the heat transfer in the system so that a coolant system would be able to use less liquid.
Overall, it was great. Like, it really helped that we all got along, and even with Professor Calicut, he was like hanging out with us, and we'll go have dinner with him and everything. It was so much fun.
It was great. Got to know the team very well, got to know the professor extremely well. There's just an immense amount of opportunities here at Purdue. I mean, we all got to fly in zero gravity, which I never thought I would be able to do in my life.
It's great. It's really good, open-ended, team-based, no answers in the back of the book. You got to deliver engineering experience for the students.
For me, anyway, it's been enlightening to see a big managerial position put upon me, and I've gotten to be able to like kind of organize a team and organize tasks to try to get everything on schedule, so to speak. Especially once we started going towards zero gravity when we had a date.
Honestly, it was the most amazing experience in my life. I gotta say that. It really felt you're doing something, right? Not just like making some calculations on paper. It really felt like you're an engineer. This is what you're gonna do tomorrow, when you go and work for a company.
My biggest takeaway is that when it comes to real engineering, when it comes to actually doing something, you can design it however you want, you can make it perfect, but there are going to be issues. Things will go wrong. How can you fix it in crunch time when you're down in Florida when the flight's the next day?
Actually, when I found out about the course, I thought you had to like apply to be in it. Like, I definitely thought you had to pay extra money. Like, I remember like talking to my parents, like if they would be able to like do that. And then I found out it was completely sponsored. You just had to sign up and be an aerospace engineering student, and I was like blown away. My mom was like, I feel like I'm really getting my money out of Purdue.
Yes, the School of Aeronautics and Astronautics at Purdue has been very supportive. The deans of engineering over the 20 years I've been doing this have been very supportive. There's one or two other places in the world you can go for a class like this, but we're doing it big time, and the Purdue name has caused a number of rocket companies to donate flights to us for suborbital flight experiments, and if this interests you, Purdue's where you should be.
Okay, we went down to 35 and a half.
No leaks in the test section. I don't see anything.
High five, everybody. Woo!
While students examine the data from the flow boiling experiment, Professor Calicut's zero-gravity class has a dozen other experiments also awaiting launch with various companies. It's proof that Purdue's School of Aeronautics and Astronautics is one of the few places in all the world where undergrads can participate in high-profile aerospace engineering projects. That wraps up another Boiler Bytes. Be sure to check us out online at boilerbytes.com. See you next time.